Assalamu alaikum students. I just received an inquiry about this question. I'm going to explain you. This is on the circle. Getting these angles by using the circle properties. So I can see lots of properties of circles can be applied over here. If you can see the figure closely, I can see here the center is given. So let me use this arc. Look at that. I'm going to use this arc, and this arc is producing angle at the center, and at the center it is making 162, and at the circumference it is making x. Everyone knows the relationship between the central angle and angle at the circumference. The angle at the circumference is always half. So 162 divided by 2. So it gives you 81. So this angle is 81, right? Now, we know by tangent segment theorem, if you have a tangent, look at that, this is a tangent and this is a chord, the angle which the chord is producing on the circumference, which is given here as 62, that angle is the same as what the chord is making with the tangent. So y is equals to 81. Y is making 81. The reason is that this angle which the chord is making on the circumference is equal to this angle which the chord is making with the tangent. Now, I want to find this z. Can you see, boys, that this ABCD is a cyclic quadrilateral? If it is a cyclic quadrilateral, the opposite to z is this angle. So, can we find this angle? We can easily find it because the total is 180. From 180, we will subtract the two angles. So let us do this, the subtraction. We will write here 180 minus 42 plus 81. 180 minus 42 plus 81. It gives us 57. So this angle is 57. And since the opposite angles in a cyclic quadrilateral are supplementary, I'm going to write 180 minus 57. 180 180 minus 57. It gives us 123. So, boys, we found angle x, which is 81. The reason is angle at the circumference is half the angle at the center, subtended by the same arc. Or you can phrase it in your own way. The property should be well understood by you. Why I found it, boys? 81, alternate segment theorem. And angle z, first I used angle sum of a triangle, 123 here. Number one, we use angle sum of a triangle to find this 57 degrees. Angle sum of a triangle is 180 degree. Number one. Second property is opposite angles in a cyclic quadrilateral are supplementary. Next question. Obviously, they are similar triangles. Which two triangles are similar? Let me explain you. TPQ is similar to SQR. They are similar. What is the reason? This angle is the same as this angle. So angle T is the same as angle R. So they are corresponding angles because we have two parallel lines. Whenever you have two parallel lines and they are cut by a transversal, we always get, um, you know, what you called corresponding angles. Do we have another corresponding angle? The answer is yes. This angle U is the same as angle Q. The reason is corresponding angles. And the third one is a common angle. Angle P is equal to angle P, which is a common angle. When the two angles are same of one triangle with the other, then we say that the triangle PUT is similar to triangle PQR. In similarity, one thing is very, very important. We can compare the ratios of the sides. So PT is 4, PT is 4. So if this is 4, I can say this is 4, this is 4. And he said that TR is 3. TR is 3. So this total is 7. This is 7. And this is also 7. Now, what do we want to compare? PU and PQ. Look at that. PU is 4. PU is 4 and PQ is 7. So 4 is to 7. Now, the PUT triangle, let me write here their ratios which are given to me. PU is 4 and 7. These are the lengths. Now, I want to compare their areas. This is the small triangle and this is the big triangle. The area of PUT, the small triangle is PUT, the small triangle is 20, and we want to find first the area of the big triangle, which is the big triangle is triangle PQR. Okay, let us find PQR, then we will come to the quadrilateral. You remember, guys, when the sides are given and we want to find the areas, we need to put the square on them, and then x will be equals to 20 times 7 squared over 4 squared. Let me get the value of x. 20 times 7 squared and then divide by 16. It gives us 61.25. Let me check it again. 20 times 7 square over 4 square, it gives us 61.25. 61.25. Now, he wants the quadrilateral area. Which quadrilateral area? Let me share it. He wants this one. So I found the big triangle area. I have the small triangle area. So why not I can subtract the small angle triangle area from the big triangle to find the area of this trapezium. So this is equal to what? Area of the big triangle minus area of the small triangle. Okay, so let's try. The big triangle area is 61.25 minus the small triangle area is given to me 20. So let's subtract. What is the answer? We got it. 61.25. Okay. 61.25 uh, minus 20. What did we get? 41.25. 41.25. So I hope, guys, you understand it. This is a very good question in which he is asking you to prove the two triangles similar. Secondly, he used the application of similarity. Thank you, boys.